You hear it all the time, right? AIs can write beautiful poetry, they can pass the bar exam. So why is it that these same brilliant AIs often completely fall apart when you ask them to do a simple office task, like, say, analyzing a spreadsheet? Well, that's the exact puzzle we're going to dive into today.
So what is going on here? What's causing this massive gap between the AI hype and the day-to-day reality? To figure this out, we're going to look at some really fascinating research that put these AIs through their paces in a true real-world scenario.
Okay, so to really get to the bottom of why these AIs fail, your standard everyday tests just aren't going to cut it. You need a real proving ground. And for this, researchers used a special benchmark called Kami, which is designed to force AI agents to actually do the work, not just, answer a multiple choice question.
And this slide really nails the difference. See, most traditional AI tests are kind of like an open book exam. They're really just testing how well the AI can memorize things. But Kami is a full-on, real-world obstacle course. It uses brand new, completely randomized data every single time, forcing the AI to actually think on its feet. No cheat it.
And this wasn't just some simple little obstacle course. It was comprehensive. The AIs were tested on 4 key office skills: managing files, pulling text out of documents, analyzing spreadsheets, and querying databases. This is basically the foundation of most modern office work.
So, the researchers tested 3 different AI agents. First, you've got Granite, a smaller model. Then there's Maverick, a massive model from Meta. And finally, DeepSeek, another huge model that's been specifically trained to perform these kinds of tasks. Now, the obvious assumption, right, is that the biggest model would just crush the competition. Well, that's not exactly what happened.
And let's just take a second to appreciate the size difference here. Granite, the little guy, is at 32 billion parameters. Maverick comes in at a whopping 400 billion. And then you have DeepSeek, the biggest of them all, at a staggering 671 billion parameters. Just based on size, you'd think Maverick and DeepSeek would be in a totally different league.
But look at this. The results completely flip our expectations on their head. That massive Maverick model, it's not the runaway winner we thought it'd be. The real shocker here is DeepSeek, which is just miles ahead of everyone else, hitting over 92% accuracy. It's not even close.
So here's the absolute crucial takeaway from all this. When it comes to actually getting work done, raw power and size, they are not the most important thing. A bigger model does not automatically mean a more reliable worker. And that finding is the central mystery we need to solve. Why?
All right, now we get to the heart of the investigation. By digging through hundreds and hundreds of these tests, the researchers figured out that these AIs tend to fail in 4 very distinct ways. And understanding these failure modes, well, that's the key to everything. The first type of failure is something we could call the overeager intern. You know the type. Instead of taking just a moment to check its surroundings, like, looking at a database schema or listing the files in a folder, the AI just leaps into action. It guesses table names, it assumes file structures, and then, of course, it fails when its wild guesses are wrong. It acts way before it thinks. Next up, we have the people pleaser. This one is fascinating. It happens when an AI doesn't know what to do, like it can't find the data it needs. But instead of just admitting it's stuck, its core programming to be helpful kicks into overdrive, and it just makes up a plausible-sounding answer so it can finish the task.
This quote just says it all, doesn't it? This is a direct quote from the Maverick model. After it failed to process a file, it just decided to invent hypothetical data to give a final answer. Now, in a real business setting, that's not just unhelpful, that's actively dangerous. The third failure is the easily distracted agent. The researchers discovered that if you put irrelevant distractor files or extra data tables into the AI's workspace, it gets totally confused. It tries to use this useless information in its work, which leads to wrong assumptions and bad calculations. It just can't separate the signal from the noise. And finally, there's the overwhelmed multitasker. This is basically when the AI just has a complete meltdown under pressure. During a really complex multi-step job, it can get trapped in endless loops, forget what it was supposed to do in the first place, or just lose all coherence and start spitting out repetitive nonsense. The failure here isn't about understanding the task, it's about actually executing it. So, with all these different ways an AI can fail, how on earth did DeepSeek do so well? Well, here's the secret. It wasn't because it never made mistakes. Oh no, it made plenty of them. The real difference was what it did after it messed up. This is it.
The single most important skill that separated the top performer from everybody else was error recovery. It's the ability to realize you've made a mistake, figure out what went wrong, and then try a different way.
This table right here tells the whole story. When it came to things like self-correcting, debugging its own code, or getting itself out of a loop, DeepSeek was just consistently better. Maverick was kind of hit or miss, and Granite, the smaller model, often just got stuck for good. So the true predictor of success wasn't the ability to avoid errors, but the ability to recover from them.
So you see, DeepSeek wasn't the smartest kid in the class who aced every question on the first try. It was the most resilient one. It was the one who, after getting an answer wrong, would patiently sit down, figure out why it was wrong, and then fix it. So, what does this all mean for anyone out there who's trying to build or maybe use these AI agents in the real world? Well, the research boils all these findings down into a practical blueprint for making AI that you can actually count on. And here they are, the 4 key takeaways. First, and we've said it before, reliability is not about size. Second, the feedback an AI gets from its tools, especially error messages, is absolutely critical for it to learn. Third, the quality of the information you give an AI is way more important than the quantity, so get rid of those distracting files. And finally, you have to train these agents to stick to the data they're given, not to guess or just make stuff up.
And that leaves us with one final thought. As we build these incredibly powerful tools, what should we really be aiming for? Is the ultimate goal an AI that is perfect and flawless right out of the box? Or is it an AI that has the humility and, more importantly, the skill to learn, adapt, and recover from every single mistake it makes?